They had laughed first, quietly in the halls of mighty, loudly in the annual policy meetings of NTT, and with absolute conviction inside the engineering floors of NEC and Fujitsu. One 1981 internal ministry memo captured the mood with cold precision. By 1990, American computational leadership will end. Their innovation model is unstable, amateur, and structurally incapable of sustaining national superiority. In Tokyo's industrial circles, this was not propaganda. It was considered technical fact. Japan's ascent was mathematical, disciplined, and inevitable. America's decline to them was simply the natural consequence of chaos. The mockery focused on Silicon Valley, a cluster of garages and hobbyist workshops pretending to be an industry. A place, as one Toshiba executive sneered, where untrained children solder circuits and call it engineering. To the Japanese bureaucratic elite, the valley looked like an undisciplined rebellion against everything they believed defined modern industry: hierarchy, planning, precision, national coordination. How could a nation with no industrial ministry, no unified roadmap, and no 5-year technology strategy possibly challenge Japan's 5th-generation computer project? How could a collection of tiny venture-funded firms compete with Tokyo's Keiretsu, which deployed more capital in a quarter than Silicon Valley generated in a year? In their eyes, America was a relic of its former industrial glory. Japan had already seized 70% of the global DRAM market, overtaken the United States in lithography yields, and built factories with defect rates American fabs could not match even with triple the workforce. The Valley, meanwhile, was busy celebrating strange ideas. Graphical interfaces, open software standards, modular architectures that Japanese planners dismissed as unscalable toys. Real national power, they insisted, came from hardware. Real computing came from discipline. Real progress came from institutions that understood how to control an industry. From Tokyo's vantage point, Silicon Valley was not a threat. It was a warning. A demonstration of what happens when a nation forgets the virtues of order. The Japanese technocratic elite believed they were watching the last convulsions of a dying empire, and America, still convinced it led the digital age while losing the industrial war beneath its feet. By 1982, senior MITI officials were briefing the Diet that the United States lacked the productive coherence necessary for long-term leadership, predicting the Valley would collapse under its own fragmentation. Yet beneath the surface of their confidence was a blind spot so large it would rewrite the global balance of technological power. Japan saw the chaos but not the engine inside it. They measured factories but not networks. They counted defects but not ideas. And as their forecasts became more certain, Silicon Valley, the amateur, the undisciplined, the directionless, was quietly assembling the one industrial machine Japan could not outplan, outgovern, or outmanufacture. This was the miscalculation that would haunt Tokyo. They thought they were challenging Silicon Valley. They never realized they were challenging the most powerful innovation system the world had ever seen. Japan's confidence did not come from arrogance alone. It emerged from numbers that looked unquestionable. Through the 1970s and early 1980s, Japan had engineered the most disciplined technological machine on Earth. MITI's bureaucrats, elite, data-driven, and ideologically united, believed they had discovered the formula for inevitable national ascendancy. Central planning for long-term strategy, Keiretsu integration for capital stability, and corporate engineering cultures built on perfection rather than experimentation. In their worldview, technological progress was not a chaotic frontier but a managed process governed by foresight, yield rates, and flawless manufacturing execution. Japan had reason to believe the model worked. Their factories produced DRAM chips with defect rates 6 to 10 times lower than American fabs. Yield improvement curves, modeled quarterly inside NEC's semiconductor division, projected Japanese cost per bit dominance well into the next decade. While American firms battled labor disputes, inconsistent quality controls, and a volatile supply chain, Japan's keiretsu networks locked suppliers, manufacturers, and banks into a synchronized rhythm. Precision was not an aspiration, it was national doctrine. Within this logic, hardware was destiny. Whoever controlled memory production, lithographic accuracy, wafer throughput, and manufacturing yield would own the digital future. And by 1983, Japan appeared to have seized all four pillars. Toshiba and NEC were pushing DRAM process nodes faster than any American competitor could match. Hitachi's defect mapping algorithms were so far ahead that U.S. chip makers privately admitted they were 5 to 7 years behind Japan in quality engineering. From Tokyo's perspective, the United States was still clinging to an outdated belief that invention, rather than execution, defined technological leadership. To Japan, that notion was amateurish, even irresponsible. This worldview shaped Japan's national projects. The fifth-generation computer project, launched in 1982, represented the ultimate expression of Japanese logic. Computing progress could be planned. Meaty theorists argued that artificial intelligence, parallel logic processors, and advanced inference engines could be state-directed into existence by concentrating elite engineering talent into a unified national effort. This was how Japan had dominated automobiles, optics, and electronics. Why wouldn't it work for computing? In their internal analyses, the United States looked structurally weak. American companies were decentralized, undercapitalized, and in constant litigation. Silicon Valley startups were not seen as innovators, but as unstable elements lacking the discipline to scale. Venture capitalists were treated as speculators, not industrial architects. And the U.S. government, fragmented across DARPA, NSF, NASA, and independent university labs, appeared incapable of enforcing a coherent national strategy. To MIT, this was self-inflicted disaster. The flaw was not in Japan's calculations, but in its assumptions. They believed technological progress emerged linearly, from hardware efficiency to system capability to national advantage. They believed the future was a machine that could be engineered the same way a factory was organized. They believed the Valley's fragmentation was a fatal weakness, not an invisible infrastructure. Japan saw disorder where there was, in fact, a new industrial logic emerging, one that would not simply outperform their model but render it obsolete. Their equations worked perfectly, but only for a world that no longer existed. And as they doubled down on manufacturing supremacy, the United States was quietly shifting the battlefield to a domain Japan had never prepared to fight in. Japan never saw the leverage point, the quiet structural mutation inside the American system that did not follow industrial logic as Tokyo understood it. While Japan invested in hardware supremacy, the United States was assembling something far more powerful. An innovation ecosystem that did not need coordination, did not require hierarchy, and could generate technological breakthroughs at a speed no ministry could predict or control. This was the invisible advantage, an economic engine built not on manufacturing perfection but on combinational creativity. At the center of it was Silicon Valley's radical decentralization. No keiretsu-dictated strategy, no ministry-defined national priorities, no corporation attempted to monopolize the future. Instead, thousands of independent actors, startups, research labs, hobbyists, venture funds, collided in dense, unpredictable ways. In Japan's planning culture, such a system should have collapsed. Instead, this collision became catalytic. Ideas did not need approval. They needed only capital. And capital did not need security. It needed velocity. Venture capital, dismissed by MITI as speculative gambling, became the United States' most potent industrial weapon. In 1983 alone, American VC firms deployed more money into early-stage computing companies than Japan had invested in its entire fifth-generation initiative since inception. More critically, VC funding cycled at speeds impossible in Japan's bank-dominated corporate structure. A Japanese R&D initiative might take 18 months to pass administrative review. An American startup could pivot its entire technical direction in 8 weeks. Silicon Valley's strength was not that it avoided failure, it metabolized it. Universities reinforced this engine. Stanford and Berkeley were not sealed ivory towers, they behaved like open-source industrial laboratories. Professors founded companies, students moved between labs and startups without bureaucratic barriers. And DARPA's contracting model, nonlinear, experimental, aggressively tolerant of failure, poured resources into open innovation rather than centralized planning. Unlike MITI, DARPA did not attempt to predict the future. It funded the conditions under which the future could emerge. Then came the paradigm shift Japan could not comprehend, the American transition from hardware-centric thinking to software-driven architectures. While Japan treated software as a secondary derivative of hardware design, the United States elevated it to the core of technological advantage. Software allowed rapid iteration, modular design, open interfaces, and exponential scalability, none of which mapped onto Japan's vertically integrated hardware doctrine. American firms realized that the battlefield was shifting from manufacturing yield to system architecture, from wafer defects to network effects, from device perfection to platform dominance. The rise of the workstation economy, Sun Microsystems, Apollo, Silicon Graphics, shattered Japan's assumptions. These machines were built on modular components, open standards, and software ecosystems that expanded faster than any planned architecture. Japan's fifth-generation computers were elegant but brittle, requiring synchronization across multiple ministries, universities, and corporations. American systems were chaotic but explosive, evolving faster than MITI committees could even schedule meetings. Japan believed national coordination created inevitability. America proved that decentralization created inevitability faster. The final piece of the invisible advantage was cultural, not economic. American engineering rewarded experimentation over obedience, cross-disciplinary thinking over specialization, and disruptive ambition over incremental refinement. In Japan, a failed project marked a career. In the Valley, it marked experience. This cultural asymmetry shaped everything: speed, risk tolerance, iteration cycles, and the willingness to discard old assumptions. Japan's hardware brilliance was unmatched, but the Valley had discovered a way to industrialize imagination itself. And so Tokyo misread the battlefield. They measured factories while America built networks. They optimized hardware while America built platforms. They perfected yield while America perfected scale. By the time Japan realized the ground had shifted beneath them, the Valley's chaotic ecosystem had already achieved something MITI's planning could never produce. A self-accelerating system that made innovation not a project, but a permanent condition. The shock arrived not as a single event, but as an accumulation of numbers, merciless, empirical, and impossible for Tokyo's planners to rationalize. For a decade, Japan had believed America's fragmented innovation landscape was structurally inferior. But by the early 1990s, the statistical reality revealed a deeper truth. Japan had lost a war it thought it was winning, and the decisive blows weren't delivered by factories but by the velocity of America's idea production machine. The first rupture came from capital flows. Between 1983 and 1990, U.S. venture capital investment in computing expanded from under $1 billion to more than $4 billion annually, a fourfold increase that Japan could not match even with MITI's largest strategic funds. Japan's early-stage investment ecosystem deployed barely 1/20th the capital of Silicon Valley during the same period. In other words, for every yen Tokyo directed through bureaucratic channels, Silicon Valley injected $20 directly into experimentation. No keiretsu, no ministry, no central bank could compete with the raw acceleration created by thousands of independent funding decisions. Then came the software avalanche. By 1992, U.S. software revenues exceeded $37 billion, over 5 times the scale of Japan's entire software sector, which remained structurally tethered to hardware manufacturers. Japanese firms produced precise code for tightly controlled systems. American firms produced platforms, Unix variants, CAD tools, development environments, databases, that multiplied their value geometrically as more engineers adopted them. Japanese reports described the trend with increasing concern. Software productivity in the United States is exceeding industrial projections by an order of magnitude. But beneath the diplomatic phrasing was panic. Japan's hardware-centric doctrine had blinded it to the realm where America was building disproportionate power. Workstation economics delivered the next shock. Sun Microsystems alone shipped more high-performance workstations in 1990 than Japan's entire fifth-generation initiative produced in a decade. The FGCS's logic machines, promised as the future of global AI, were still laboratory prototypes requiring controlled research environments, while American Unix workstations were populating universities, startups, aerospace labs, movie studios, and financial firms by the tens of thousands. Each workstation became a node in a rapidly growing software ecosystem. Japan's state-planned architecture simply could not replicate the viral expansion of America's decentralized platforms. The semiconductor numbers were even more devastating. Japan still dominated DRAM production, but U.S. firms had quietly shifted the battlefield. Instead of fighting to regain memory supremacy, America redirected R&D toward microprocessors, custom logic, and fabless design, a sector Japan had not anticipated. By 1994, U.S. semiconductor R&D spending surpassed $12 billion, or nearly double that of Japan. Intel's x86 architecture exploded from 10 million units per year in the mid-1980s to over 70 million by the mid-1990s. Japan had perfected memory. America had captured the brain, every data point hammered at Japan's ideology. MITI's post-mortem analyses showed that the fifth-generation computer project, intended to lead the world into an era of knowledge processing, had failed to produce commercially viable technologies. Meanwhile, DARPA-funded American labs, operating with no unified national strategy, had delivered breakthroughs in networking, distributed systems, parallel processing, and early machine learning methods. Tokyo's planners, who believed centralization was strength, were forced to confront a painful truth. Decentralization scaled faster. The psychological blow was severe. When Japan's Ministry of Posts and Telecommunications evaluated the global shift toward open network standards in 1993, the internal report concluded with uncharacteristic bluntness. The United States has created an innovation system that exceeds the predictive capacity of our planning models. It was an admission that the very tools Japan used to understand the future had failed. Factories' precision and manufacturing discipline had not saved them. America had won because the terrain of global competition had changed, and Japan's institutions could not adapt to a battlefield where speed mattered more than control. The data did not just undermine Japan's strategy. It broke its worldview. By the mid-1990s, the numbers were no longer merely unsettling, they were existential. Tokyo's planners, once certain of Japan's inevitable ascent, found themselves confronting an unthinkable reality. America had not just pulled ahead. It had rewritten the rules of industrial competition so completely that Japan's entire developmental model no longer mapped to the new technological landscape. What began as quiet doubts inside MITI corridors became over a few short years a full ideological collapse. Engineers inside NEC were the first to voice what bureaucrats refused to say aloud. In confidential post-FGCS reviews, project scientists admitted that Silicon Valley's so-called chaos culture had produced more commercially viable AI tools than Japan's decade-long national project. MITI had envisioned logic-based inference machines. The Valley delivered scalable software architectures, neural network toolkits, distributed computing frameworks, and parallel processing hardware that adapted faster than Japan's committees could convene. A senior engineer summarized the shock in a single line. "We built monuments. They built momentum." The psychological rupture deepened as Japanese firms tried to compete in the workstation and software markets. Fujitsu's Tron-based operating systems, hailed as Japan's answer to America's open architectures, struggled to secure global adoption. Meanwhile, American systems multiplied at a pace Japan had never witnessed. Each new workstation installed in a U.S. lab seeded new software, new protocols, new startups, new feedback loops. Japanese engineers had mastered manufacturing yield. Americans had mastered ecosystem yield. The distinction shattered Japan's industrial confidence. Inside Japan's policy establishment, the reckoning was brutal. MITI's internal evaluations of FGCS, declassified years later, revealed profound dismay. The project failed not because of insufficient funding or poor engineering, but because the underlying logic of central planning could not keep pace with decentralized innovation. The ministry had assumed that concentrating national talent would produce breakthroughs. Instead, America's fragmented, competitive, risk-embracing environment produced far more. The Valley did not wait for permission, consensus, or hierarchy. It iterated, failed, recombined, and scaled. refusing the very constraints Tokyo believed defined technological order. The ideological disintegration accelerated when Japanese analysts examined how the United States integrated universities, private capital, and government R&D. For decades, Japan assumed America's disunity was a disadvantage. Now the evidence showed the opposite. Modular coordination across independent institutions created a form of industrial agility Japan's vertically integrated system could not match. DARPA's project managers wielded budgets with a speed that MITI administrators could only envy. Stanford's fluid movement of researchers into startups violated every Japanese norm of bureaucratic propriety, but it produced compounding cycles of invention. American venture capital, once dismissed as reckless speculation, had become a national force multiplier. By 1995, Japanese policymakers spoke openly of a speed deficit, the recognition that Japan could no longer adjust to technological transitions quickly enough to compete with Silicon Valley's acceleration. Hardware cycles lengthened, software cycles shortened. Japan's culture rewarded precision. America's rewarded disruption. Tokyo realized that no amount of manufacturing superiority could compensate for disadvantage in innovation velocity. Yield rates could be improved by engineering rigor, but adaptability required the one trait Japan's industrial bureaucracy had never cultivated: institutional looseness. The collapse was not merely strategic, it was personal. Engineers who had devoted their lives to the fifth-generation dream felt betrayed by the system that promised inevitability. Bureaucrats who once lectured visiting Americans on planned superiority now studied Silicon Valley playbooks with a humility that would have been unthinkable a decade earlier. The defeat was total because it was conceptual. Japan had not been beaten by better hardware. It had been defeated by a system fundamentally more adaptive, more chaotic, and ultimately more powerful. Japan's planners had believed that discipline created destiny. Silicon Valley proved that in the age of exponential technology, discipline without dynamism ensured decline. In the aftermath of its strategic failure, Japan faced a truth that would echo far beyond its own borders. Silicon Valley's triumph was not the victory of one industry over another, but the emergence of a new global operating system for innovation. America had not simply outproduced or out-engineered Japan. It had demonstrated that in a world defined by accelerating technologies, the most powerful advantage was the ability to reorganize the future faster than anyone else. The legacy of this shift became visible almost immediately. By the late 1990s, international policymakers, from Europe's Directorate General for Competition to South Korea's Ministry of Information and Communication, quietly abandoned the Japanese model of central planning for high technology. They adopted America's decentralized formula: open standards, venture-driven ecosystems, university-commercial fusion, and government institutions designed not to control industries but to ignite them. Across the world, innovation zones began to imitate Silicon Valley's cultural DNA. Informal collaboration, rapid prototyping, fluid labor markets, and an almost reckless tolerance of failure. What Japan had treated as undisciplined chaos had become recognized as the architecture of the 21st century economy. The shift in strategic doctrine was profound. Manufacturing precision, once the heart of national industrial power, yielded ground to ecosystem strategy. Nations no longer sought to control entire supply chains through vertical integration, but to dominate critical layers, software, networks, architectures that exerted disproportionate leverage over the whole system. This was America's true victory, not a triumph of factories but of frameworks, not the perfection of components but the mastery of connections. The Valley taught the world that innovation was no longer a linear process but a combinational one, where breakthroughs emerged from dense feedback loops between academia, capital, and industry. Tokyo understood this lesson with a clarity carved from defeat. As Japan restructured its industrial policy in the 2000s, it quietly dismantled the pillars that once defined its technological confidence. MITI itself dissolved, replaced by MITI, an institution forced to acknowledge that the age of grand centralized technological projects had ended. Japanese firms broke apart their rigid vertical hierarchies, outsourced software development, embraced global standards, and sought partnerships with the very American companies they once dismissed as amateurish. Even in cultural terms, Japan's engineering establishment began to reinterpret failure, not as shame, but as part of creative iteration. But the deepest legacy was psychological. For half a century, nations had believed that industrial greatness required discipline, coordination, and mastery over uncertainty. The United States showed that the opposite was true. Strategic dominance now emerged from the ability to harness uncertainty itself. In Silicon Valley's world, unpredictability was not a threat to be contained but a resource to be exploited. Systems that embraced disorder became adaptive. Systems that feared it became obsolete. Japan's planners eventually put this realization into words. A 1998 MITI review, rarely quoted outside policy circles, summarized the collapse of their old worldview with painful precision. We attempted to predict the future. The United States built the mechanisms through which the future continuously recreates itself. In that quiet admission lay the full recognition of what had happened. Tokyo had challenged Silicon Valley with hardware superiority, industrial discipline, and bureaucratic confidence. But America owned the future because it built a system capable of permanently generating it. The final lesson is stark and enduring. Industrial power in the late 20th century no longer belonged to those who perfected the machine, but to those who mastered the engine of innovation. And in that domain, the United States did not just lead. It rewrote the definition of leadership itself.